Okay, so let me go over again the um, the ladder problem that we started in class. In some of the classes, I was able to finish it. In some of the classes, I was just able to rewrite or identify all the information needed. So, whenever we have a ladder problem, right away you should start thinking of a right triangle. So here's my right triangle, and and identify what particular measurements are constant. That means they remain the same. In this case, the ladder is 20 feet long. So this particular ladder right here will never change. It remains 25 feet. But then they're telling you here that it's against the wall. So here it is. The bottom of the ladder is pulled away. So what you have now is the ladder is being pulled away. I'm pulling it away right there. And so as you start noticing this right here, the rate is changing every time you start pulling away from the wall. This right here, the y, the rate of y is also changing because it's dropping, it's moving down. So I can think of it as there is a rate in which y is changing, there is a rate in which x is also changing. But the problem though is that it's always with respect to time. Jeez, what am I doing? With respect to time. Okay? Respect to time. So let's identify any information that is given. Right here. The bottom of the ladder is pulled away at a rate of 3 feet per second. This right here, this measurement, the rate in which the ladder is being sort of pulled away from the wall is changing at a particular rate. How fast is it moving? Well, as I start pulling away from the wall, from the bottom, right there, is happening at a rate of 3 feet per second. So I know then that this particular rate is dx dt. And how fast am I changing? How fast am I moving when I start pulling away from the wall? Well, that happens at a rate of 3 feet per second. The question they're asking you is, how fast is the top of the ladder? This is the bottom of the ladder, right here. This is the top of the ladder, right here. Okay? Right here, bottom, top. So let's make sense of this. How fast is the top of the ladder dropping? So here's the top of the ladder, so it's going to follow this particular distance. It's going to start dropping this height. So it's going to start dropping. It's going to start moving down, sliding down, whatever word you want to use, but it's going to be sliding down. So that's what they want to know. How fast is the ladder moving down when the bottom of the ladder, I wanted it specifically when the bottom of the ladder is 15 feet from the wall. So I know that I pulled the ladder already. So I started with something like this. Now I want to know when it's 15 feet. How fast was this dropping at that instant? Okay? So here we go. They want you to find, that's where we want to do, find, right there, find how fast dy dt, the top of the ladder. That's why I selected dy dt. This is the top of the ladder, and that belongs to this y variable. When the bottom is x equals 15 feet. Now I need an equation that relates these particular variables and this particular figure. I know that I can use x squared plus y squared. I know it's equal to z squared. But because we already know that this is the hypotenuse is 25 feet, so I set it equal to 25 feet squared. Now, since I have different variables, I'm going to differentiate with respect to time. X squared plus y squared. Differentiate with respect to time. Left both sides of your equation. When I differentiate x squared with respect to time, look at the variables. That's one way to know when is it that I add dx dt. Well, if you were just to take the derivative of x squared, that would just give you 2x. But then I know that x is changing with respect to time, so I need to multiply by dx dt. And one way to know when I need to multiply by dx dt is because we have a different variable. Plus the derivative of y squared with respect to time. Again, is 2y, different variables, so dy dt. And the derivative of a constant is 0. Now, so already differentiated with respect to time. Do I have enough information to substitute? Well, I know that x is right here. They give you that is 15. I know that dx dt is 3 feet, so I can substitute that in. But I don't know anything about y. From the given, there is nothing given about y. But I know that I have this particular equation that I can use, that I'm able to use, and I'd be able to solve for y. Why? Well, I know x is 15. So I can say x squared plus y squared equals 25 squared. X is 15 squared plus y squared equals 25 squared. That gives you 225 plus y squared, 625. Y squared is 400. If you take the square root of both sides of the equation, you get that y equals plus or minus 20. But since we're talking about distance, minus 20 doesn't make sense. So now I'm able to substitute all the information. Since I want to know dy dt, that's the only quantity that will not be replaced since I want to solve for dy dt. So now 2 times x, as x is 15, dx dt is 3 plus 2 times y. Y we found that is 20, and I know that I need to find dy dt, and that equals to 0. Now, I know that I have a common factor of 2. There's a 2 there, there's a 2 there. Well, I can just do this, and that will go away, and I still have 0 here. So 15 times 3, that gives you, I'm going to do it right here, 15 times 3, that gives you 45 plus 20 dy dt, and that equals 0. Minus 45, 20 dy dt equals negative 45, divided by 20. I know that dy dt is divided by 5, that gives you negative 9 over 4. Since I'm talking about y is in feet, y is right here is feet per time. What's the time? Seconds. So that's what you have. So I'm going to erase this because now we need to answer the question, and that's what you're going to do on the AP exam. Alright, so how do we answer the question? Right here. How fast is the top of the ladder dropping? So you start with the sentence right here. the top of the ladder is dropping, sliding down. The top of the ladder is dropping at a rate of, what's the rate that we found? The rate is at a rate of -5/4, -9/4 feet per second, when the bottom of the ladder is 15 feet from the wall. Right there. And that's the end of the problem. So if you notice, there is one mistake right here because I put a minus. And it shouldn't be minus there because I already said that it's dropping here. So that should take care of the minus sign. So be careful. The top of the ladder is dropping at a rate of 9.4 feet per second. So be careful right there. That word right there is already taking care of that particular sign. Okay? All right.